Hey everyone, Rob here, and I've got a new board up on the website for sale under the products page. It's a PowerFet booster pack for TI's Launchpad. It just plugs in on top of the Launchpad like most of the other booster packs do. It's got two 10-pin headers that you can solder on, so it just plugs right in. And this is a motor controller. It can control two loads. It's got two 2-pin locking headers on it, and so you can control two independent loads. And it's got a two N-channel MOSFETs. There's a single package dual MOSFET device, and these control a couple amps a piece. And so I've got some video coming up after this to show you it in action. It's controlling an LED strip that's at 12 volts. I think it draws about half an amp. But they're pretty cool little boards, and paired up with the Launchpad for about 25 bucks, you can have an individually addressable via I2C motor controller or load controller. And so there's a barrel plug on here that lets you plug in your own power supply, so you can deliver 9, 14, 12, 15, 18 volts to whatever load you're trying to control. And there's 4 LEDs that you can play with, power LED, and I2C connection is also a 2-pin locking header, so you can create a small cable harness to attach this to an embedded system or attach some of these together and have a remotely individually addressable motor controller. And so if you have any questions, feel free to contact me. Any comments, post on the blog. And so the next part of this video will be a quick example of this thing in action, controlling an LED strip. And this particular LED strip, I think, draws about half an amp at 12 volts or 14 volts. And so I've got a 12 volt power supply that can handle up to 4 amps. I've only got one strip on there right now, but you can see it working. It works pretty well, and I'll show you some examples of pulse width modulation, some source code, and have some write-ups to kind of make it a little easier to understand how to use this and how it can be useful. So thanks for checking out my blog, and feel free to go through the rest of it. Contact me with any questions or comments. Thanks. So here's a quick demonstration. I've got this booster pack set up on the Launchpad, and it's tied. One of the FET outputs is tied to a LED strip that draws about half an amp, and that'll be my load. And I've got a scope probe hooked up to here, which is going to be the ground side that we switch on from the FET that's on the Launchpad, and that's tied into an oscilloscope over here. You can see, so this way we can see the pulse width modulated signal as the duty cycle walks up to 100%. And so you can see here also that the load is on, and the board's running. See some LEDs there. So if we hold it and reset, it powers off, and you can see on the scope that that FET is held up at 12 volts with our 12 volt input right here from our power supply. And when you power the FETs on, they're N channel and they switch to ground, and so you'll see the duty cycle walk up to 100%, switching on ground. And so when we let it power up, you can see it start to open up just like that. This is running at about 5 kilohertz, and I've got a reset button, so you push this and you can see the light power back on. Now you see the duty cycle start over. We reset that. And so this works pretty well. This is pulling a half an amp. This power FET on here will handle a max of a couple amps. So there's a decent amount of power, and this is on a 12 volt power supply that can handle up to 4 amps. So it's a pretty good little load controller, motor controller type thing. And all this code in this example I'll put up in the post below that, but it's just a quick demonstration. This board's up on the website. You can order it as a kit to build yourself. It's all surface mount parts, and I think the smallest parts are 0805s, so it's not too hard to build. So this is a fun little kit. It's got 2 power controllers. These are 2-pin locking headers, and then On the rightmost side, it's got an I2C plug too, so you can connect up, link these together, or create an I2C bus with pretty much anything. And you can see that if this probe's moved, you can see that over here. Right there, you've got I2C and the pull-ups for that. So check it out. There's a write-up, more details, and some more discussion about this board. Email me with any questions.